Okay, welcome back. This is Honors Math 3, and Unit 3, Worksheet 6 is really just review of the last objective or two, and so we're not doing that worksheet. We are moving on to Worksheet 7, so this, I guess, if we're going to keep up with the numbering on the worksheets, this is 3.7. So 3.7, we are factoring things that we're probably unable to factor any other way other than by division. Okay, so if R is a root or a zero of some polynomial function P of X, then X minus R is a factor of that polynomial function P of X. Now that we already talked about in a previous set of notes. But here's something else, and hopefully it's relatively obvious. If we divide the polynomial function P of X by that factor, X minus R, the remainder will be zero. Now, hopefully that's fairly obvious. Why would we do that? Well, we'll see as we're going through and doing some of the problems. Now, division. We have long division, okay? And so here we go. We're doing x to the third plus 4x squared minus 11x minus 30 divided by x minus 3. Okay, so long division, we've got the I don't even know what to call it. The division house, the division symbol for long division. What goes on the inside, what goes on the outside? Well, the thing you're dividing by, the divisor, goes on the outside. So we're dividing by x minus 3, that goes on the outside. And what is being divided, that goes on the inside. So x to the third plus 4x squared. Now, by the way, it's a good idea to pay attention. Have it in descending powers of x. If it skips a power, you could put a placeholder with long division. You don't necessarily have to. But you do want it in descending powers of x. So x to the third plus 4x squared minus 11x minus 30. Okay, now when we're doing the long division, I think it's very important to have an alternate color there that's very noticeable, and explain why here in just a minute. Okay, now x minus 3 into x cubed, but really just focus on the first. So x into x cubed. How many times? Or maybe the best way to do it is what times x will give me x to the third? What times x will give me x to the third? Well, x squared. So x squared. Now, we don't necessarily have to write it lined up with anything necessarily. I've just got an x squared up there right now. So x squared times, now I'm going to multiply x squared times everything that's out here. So x squared times x is x to the third. X squared times negative 3 is negative 3x squared. Okay, now maybe it's been a long time since you've done long division, but what do we do at this point? We subtract. And when you subtract, you're subtracting this whole thing, which means we need to distribute a negative. And so that's why I think it's very good to have an alternate color here. So I'm subtracting, I'm going to distribute my negative, and now because it's a different color, I can actually see that I did distribute my negative. Now, the first terms should always eliminate each other, otherwise we have done something wrong. So the x cubes, they're gone. I've got 4x squared plus 3x squared, that's 7x squared. Of course, what do we do at this point? Well, you bring the next term down, so negative 11x. And we kind of start the process over again. So either x goes into 7x squared, how many times, or what times x gives me 7x squared? Well, 7x, a positive 7x, times x will give me 7x squared. So 7x times x is 7x squared. 7x times the negative 3 is negative 21x, and we are going to subtract, so I need to distribute a negative. First terms eliminate. I'm left with negative 11x plus 21x, which is 10x. I bring down the next term, which is negative 30. Okay, what times x gives me 10x? Well, positive 10. Okay, so 10 times x is 10x, and 10 times negative 3 is negative 30. And if I distribute my negative, because I'm subtracting, we notice that we get 0 coming from that. Now, this is the remainder. And so since our remainder is 0, therefore, since remainder is 0, x minus 3 is a factor of the polynomial function. Okay, if we're saying that this is our polynomial function, p of x, okay, so x minus 3 is a factor of p of x. And 3 is a root, a 0 of p of x. Okay, so since x minus 3 is a factor of p of x, then what this allows us to do, we were unable to factor p of x by normal methods. I mean, there's 4 terms, but if we tried grouping, that's really not working. But we have reduced p of x by finding this factor. So x minus 3 is a factor, so we would have x minus 3 times the quotient here, x squared plus 7x plus 10. And so we've started the factoring process. So now the x squared plus 7x plus 10, hopefully we recognize the fact that we can actually factor that further. And that's the idea behind factoring by division. We find factors by division and reduce the polynomial to a point where we can finish factoring it. And so we recognize that we can finish factoring the polynomial as x plus 5 and x plus 2. And so the finished, completely factored over the integer form for p of x is x plus 5 times x plus 2 times, don't forget about the x minus 3, times x minus 3. It doesn't really matter what order we have those 3 factors in, it's just that's the completely factored form for p of x. Now, if it's strictly asking you for the answer to the division problem, well, the answer to this division problem is the quotient, and we can find the quotient here, x squared plus 7x plus 10. And since the remainder is 0, we don't need to worry about including the remainder. So there's the answer to the division problem, if really all they're interested in is just the division problem. Sometimes that's all they're really interested in. Let's try another problem here now. So problem number 2. Is x plus 4 a factor of p of x if p of x is the polynomial function x to the third minus 17x minus 8? Okay, now we only know one method for division at the moment, so I am actually going to teach you another method for division after this problem. So let's set it up though. We've got, we're dividing by x plus 4, so x plus 4 goes on the outside. We are dividing x to the third minus 17x minus 8. Now it's in descending powers of x. Notice it did skip x to the second. You could do a placeholder. You could do plus 0x squared, and some people really like doing that. If you just give yourself a little bit of space, maybe not squish it up really tightly, then you're okay as well. So minus 17x minus 8. Okay, and so we start the process over again, and so we say what times x gives me x cubed? Well, x squared. So x squared times x plus 4, we would get x cubed plus 4x squared. We subtract, different color, distribute that negative. First terms eliminate. Now, here's where it's a little bit, this is maybe where it's nice to have the 0x squared. Like I say, you don't have to, but 0x squared minus 4x squared is negative 4x squared. Bring down the next term, negative 17x. What times x is negative 4x squared? Negative 4x. So negative 4x squared minus 16x. Subtract, distribute the negative. First terms eliminate. Negative 1x, bring down the last term, minus 8. What times x gives me negative x? Well, negative 1. So negative 1 times x plus 4, we get negative x minus 4. Distribute the negative because we're subtracting. And we get a remainder of negative 4. Okay, there's our remainder. Now, is x plus 4 a factor of p of x? Well, no. Short, simple answer is no. Why? I mean, we've shown why. If the remainder is anything except 0, then x plus 4 is not a remainder. But let's write that out. No, since remainder is negative 4. Okay, so we've answered that question. Now, much like what I was talking about on the previous problem, sometimes we just need the answer to the division problem. And so if they're just asking you, what is the answer to this division problem? Well, the answer to the division problem is x squared minus 4x minus 1, so all of that stuff up there. But since the remainder is not 0, we need to include the remainder as part of the answer to the division problem. So plus whatever the remainder is, negative 4, over the thing we're dividing by. We're dividing by x plus 4, so over x plus 4. There is the answer to the division problem. Okay, so at this point now I'm going to teach you another method of doing division, and so that's the next problem that we will be doing. Another way to be able to do division algebraically, it's known as synthetic division, and we're going to redo problem number 2 synthetically. So, is x plus 4 a factor of p of x? Okay, so we're going to check. Now, okay, so synthetic division. So out to the left, there's a partial box, and in that partial box is what we're dividing by, but we don't put the entire x plus 4. So what would we plug in for x to make that 0? Negative 4. So negative 4 is what we put in the box. So instead of putting the x plus 4, you're saying, okay, what value of x would I put in there to make it 0? That's what you're dividing by. Okay, then going to the right of the box, we're going to be doing coefficients of the thing that we're dividing. And if it skips a power, you must put a placeholder. So we have 1x cubed, so 1. We have 0x squareds, so 0. We have negative 17x's and negative 8 without any x's or with x to the 0. Skip a line, draw a line underneath right there, and it's all set up. It's ready to start doing synthetic division. Okay, so here's how it goes. The first number, it just kind of goes down and it goes beneath the line right there. So there's a 1. You could also say that it's 1 plus, well, what's the number that's written right there? It's a 0. So 1 plus 0 is 1. So regardless, the first number just goes down below the line. Now, the number below the line is multiplied by the number in the box. Negative 4 times 1 is negative 4, and is put above the line at the next spot. Now we combine the two numbers above the line. 0 plus negative 4 is negative 4. That goes below the line. And the number below the line is multiplied by the number in the box. So negative 4 times negative 4 is positive 16. Goes above the line. So negative 17 plus 16 is negative 1. Goes below the line. And then negative 4 times negative 1 is positive 4. That goes above the line in the next spot. And finally, negative 8 plus 4 is negative 4. Now, the remainder is right here. The last spot below the line, that's the remainder. So in answer to the question, is x plus 4 a factor of p of x? No, since the remainder is negative 4. And any remainder besides 0 means that it's not a factor. Now, if we were just interested in the division problem, the answer to the division problem is there. It's just we have to construct our answer a little bit. And so the answer to the division problem now realize we were dividing x to the third minus 17x minus 8, dividing all that by x to the first. And so if I'm doing x to the third divided by x to the first, don't we get x to the second? So this first term right here, that's the coefficient of the x to the seconds then. And so I have 1 x to the second. I have negative 4 x to the first. I have negative 1 x to the zeros. And then here's my remainder plus the remainder over the divisor. Now remember, the divisor is x minus whatever's in the box, so x minus a negative 4. So dividing by x plus 4. There's the answer to the division problem. Now, once you get used to synthetic division, it is very nice, it's quick, it's efficient. You're going to like being able to do it. We still need long division because sometimes synthetic division has some limitations. We can only divide by x to the first things. So if we were having to divide by x to some other power, we would need long division. But if we're just dividing by x to the first kind of thing, synthetic division is very quick and efficient, and it's a very nice way to be able to do it. Okay, so we are going to go ahead and do another problem, and I'm going to employ the synthetic division with this, okay? So problem number 4. Given f of x equals 3x to the third minus 4x squared minus 28x minus 16 and x plus 2 is a factor of f of x, We want to factor f of x completely. Find all of its roots. And sketch. Now we did kind of a similar thing, essentially on problem number 1. We did that by long division. I mean, if we look at this problem, I mean, it's 4 terms, we could try grouping, and it doesn't seem to be working very well. So, but we're guaranteed, we were told that x plus 2 is a factor, and so therefore it will go in evenly, and so we're going to take advantage of that, but instead of doing a long division, I'm going to do it synthetically. So I'm going to divide by x plus 2. So I'm going to put negative 2 in the box, because what would make it 0 in there? Negative 2. That's what I'm dividing by. I did not skip any powers of x, so just put them in order. 3, negative 4, negative 28, negative 16. Skip a line, draw a line underneath. Now, as long as we do everything correctly, we are supposed to get 0 for the remainder. Now, don't put 0 there already. I mean, let's see if we get 0, because if we don't, we've made a mistake. First number just comes down, it's a 3. Number in the box times the number below, negative 6, goes above the line. Combine them, negative 10. Multiply by the number in the box, 20. Combine, negative 8. Number in the box times that number is positive 16, and that's good because we get remainder of 0. So yes, that's happy, we're good, we're glad. Now, much like on problem number 1, how I showed you that we have reduced the equation, we have reduced f of x. Effectively, we know right now that f of x is x plus 2 times this. Now, what is this? Well, it's 3x to the third divided by x to the first, so it's 3x squared minus 10x minus 8. Now, the direction said factor completely. Hopefully, we can handle factoring the 3x squared minus 10x minus 8. And so if we check that out, we should have 3x and 1x. And multiplies to get 8, so probably 2 and 4. Do I want to do 3 times 4 or 3 times 2? It could work either way. I think I'll try the 3 times 4. Put the 2 there. Let's see. Negative 12x, positive 2x, and then I get a negative 8 at the end. Okay, so f of x is 3x plus 2 times x plus 2 times x minus 4. And so we were able to factor that one completely, whereas we might have been stumped otherwise without being able to do this by division. And the synthetic division is very nice. Right now, what are all my roots? My roots, since it's a third degree, I know I should get 3 roots. My roots are negative 2/3, negative 2, and positive 4. So I have 3 roots. All of them are x-intercepts and multiplicity 1, so that they all go through. Quick sketch here. So we've got negative 2/3, negative 2, positive 4. This is a positive 3x to the third. So it is a low to high. Starts low, each one goes through. Label all your intercepts. And if we plug in 0 for the x's, where's the best place to plug in 0 for the x's? It's actually the easiest place is where it's not factored for the y-intercept. So if we do that, we get negative 16 for the y-intercept. Okay, and there's y equals f of x. Okay, so we're going to do another problem similar to that last one. It's a little bit more complex. So we're going to factor the polynomial completely if, here's the polynomial, p of x is negative 3x to the fourth plus x cubed plus 67x squared plus 51x minus 180. And if 5 4/3 are zeros of p of x, and we'll sketch it too. Now, first off, what makes this at least a little bit different is the previous problems I was telling you factors. Well, if 5 is a 0, doesn't that mean that x minus 5 is a factor? And then we can work with the 4/3 as well. Now, if x minus 5 is a factor, what would I put in the box when I do the division for synthetic? Wouldn't we put 5? So it's a little bit different, but if they tell you something is a root or a 0, they're telling you exactly what to put in the box. So we're dividing by x minus 5 when I put a 5 in the box. Okay. Next, we do set up the rest of it. So I've got negative 3, 1, 67, 51, negative 180. Skip a line, draw a line underneath, and it's all set up, ready to go. So first number just comes straight down, negative 3. Number in the box times that, negative 15. Combine those two, negative 14. Multiply. 5 times negative 14 is negative 70. Combine those two, negative 3. 5 times negative 3 is negative 15. 51 and negative 15 is 36. 5 times 36 is positive 180. And we do get a remainder of 0 just as we're supposed to. So it worked. Now, it is important when we're trying to reduce the equation that we work with the reduced polynomial. So I'm going to do that little squiggly line. I think you saw me do one of those on the last problem. I'm separating the remainder from the other part. I'm going to draw a line underneath there because I'm getting ready to do synthetic division again. Okay, picking up where I left off. It is important for us to do division with the reduced polynomial. The original polynomial was negative 3x to the fourth plus x to the third plus 67x squared and so on. Once I've divided by the x minus 5, this is now negative 3x to the third minus 14x squared minus 3x plus 36. And so I'm working with the reduced polynomial, and now I'm going to divide by 4/3. Okay, because if 4/3 is a 0 of the polynomial, then it will work. I'm dividing by x minus 4/3. Yes, we can work with fractions. Okay, so here it goes. Negative 3 comes down below. 4/3 times negative 3 is negative 4. I get negative 18 if I combine those two and I multiply by 4/3. And so I get 4 times negative 6, which is negative 24. And if I combine these two, I get negative 27. And if I multiply by 4/3, I get 4 times negative 9, which is negative 36, and I get 0 just like I'm supposed to. So it was good that we got 0 remainder for both of those. We were supposed to because it told us those were zeros of the polynomial. And if we're not getting 0 for the remainder, then we've done something wrong. Okay, now whatever's left, we've gone from a 4th degree polynomial to a third degree polynomial to a second degree polynomial. Now, whatever is left, we need to be able to finish factoring it. First, let's make sure we write out what it is. Like I said, we started with fourth degree, then it's third degree, now it's second degree. So this is negative 3x squared minus 18x minus 27. Now, anytime you're dividing by a fraction right here, you're going to see a GCF of that denominator in whatever's left. Notice that there is a GCF of 3. There's actually a GCF of negative as well, -1. So let's go ahead and do the -3. So -3 GCF, and we would have x squared plus 6x plus 9. Okay, and of course, x squared plus 6x plus 9, that's x plus 3 times x plus 3. In other words, x plus 3 quantity squared. And I think we're ready to write our polynomial p of x in factored form. So let's keep track of everything we're supposed to have. P of x in factored form. We have a GCF of -3. Don't forget about that. So -3. We had x plus 3 times x plus 3. In other words, x plus 3 quantity squared. We also had 4/3. Now, and I know I've taught you how to create the factor without the fractions. Let's just do x minus the 4/3 at the moment. X minus 4/3. And we also have the 5, which that as a factor is x minus 5. Okay, now remember that GCF of 3 that we pulled out? So the 3, we want to take that GCF and find the one with the fraction, and we're going to multiply the 3 times the factor that has the fraction. I'm going to distribute it to both parts, and so if I distribute the 3 to that, wouldn't we get 3x minus 4? Okay, so P of x is, now the negative's still there. But we have x plus 3 quantity squared times 3x minus 4 times x minus 5. Now you can put the factors in any order you want. The GCF of -1 should be out in front. So there's the completely factored form. All of our roots, our zeros, are -3 multiplicity 2, 4/3, and 5. So we have a total of 4 roots when we include the multiplicity. We had a 4th degree. We should have 4 roots. We have 3 x-intercepts. And we are ready to sketch the graph here. Okay, so we have -3, we have 4/3, we have 5, overall, this was a -3x to the 4th, and so it's a low to low. So it starts low, ends low. It bounces at -3, goes through at the other 2. So it starts low, bounces, get about halfway, you got to turn around, goes through, ends low. Label all your intercepts, -3, 4/3, 5, and our y-intercept, if we plug in 0 for all the x's, well, if you look back at the top, plug in 0 for all the x's, and it's -180. So, -180. Okay, now there's just one more thing that I'd like to point out to you. I mean, this is how we can use the division to help us do factoring problems. and it was kind of on the verge of doing it right here. Sometimes we want to be able to evaluate the function at a certain value. So, for example, if I wanted p of 5 for this function, if I wanted p of 5, it was 0. And so the remainder is the value of the function, is what I'm trying to tell you. So, for example, if I wanted p of 1, if I wanted p of 1 for this function, still looking at this function. Obviously, you guys have done this before, in probably even back in Math 1 or even before that. But if we do p of 1, we're just inputting a 1 wherever we see the x's. So I would have -3 times 1 to the 4th plus 1 cubed plus 67 times 1 squared plus 51 times 1 minus 180. And so obviously this works, and we're able to figure out what p of 1 is. So we would have, let's see, -3 plus 1 plus 67 plus 51 minus 180. And so we get -64. So 1 comma -64, which if we kind of look at that, yes, that's plausible because at 1, we are below the x-axis, and we see that the y-intercept at 0, we're at -180. So 1 comma -64, that seems plausible. Now, another way to get the value of a function is what is known as synthetic substitution. And I'm just telling you, we need to be able to do it because sometimes it's very important for us to be able to do it this way. It's almost exactly the same as synthetic division. Two differences. First difference, they tell you exactly what to put into the box. So for example, if we're doing p of 1, we put in a 1. Much like if we told you something is a root, you know, like on the problem we told you 5 was a root and 4/3 was a root, we just plugged into the box 5 and 4/3. So I'm putting in a 1. The rest of the setup is exactly the same. So if I put in the 1 into the box, and then I have -3, 1, 67, 51, -180. Skip a line, draw a line underneath. Okay, and then the process works exactly the same as with synthetic division. So -3 comes down. 1 times -3 is -3. Combine, I get -2. 1 times -2 is -2. And I get 65. And 1 times 65 is 65. And I combine those two, and I get 116. And then 1 times 116 is 116. And if I combine those two, I get -64. And notice that the remainder, that is p of 1. It's the exact same thing as we got right there. And I'm telling you that we need to be able to be okay with synthetic substitution.